Okay, good morning, good morning, good morning. Happy Friday. Happy Friday. Weather got a little warmer, so it's a little better. We actually had snow flurries the other day. Did y'all get snow flurries? It was kind of spooky. It's too early for snow flurries. Alrighty. Oops. Sorry about that. All right, this is what I want for you to look at. So we're going to do that worksheet today. So while we're waiting for folks to come in, um, pull up the worksheet. We're in all right, so this is what we're working on today. And if your body's in the room today, you need to have it finished and submitted today. So I'm going to walk through it with you, show you how to do it. Go back over the top of the worksheet again, and everybody's going to have this finished today and submit today. All right, while I'm here, I also want to point out that the very next lesson also has the chart and everything in it. It has a little paragraph that explains what's going on. It has both paragraphs that I was telling you about, so I'll go back over those. Um, so the next week we're going to talk about mutation. So it's important that you understand how this goes, because next week we're going to look at doing the same thing, coding the same way, except we're going to look at how we get a mutation. Okay, so ask questions if you don't understand, because you need to form a foundation of understanding before we can go on to the next one. Okay? All right, speaking of a foundation, some of you need, hold on, let me let Xander in. Okay. Let's see. People still missing. All right, but they're late, so I'm going to go ahead and get started. All right, there she is. Still one more. All right, backtracking a little bit. What you need to remember is this started in the nucleus. We make a copy of DNA, and it's like a mirror image. So the DNA opens up, the messenger RNA. The other thing we need to remember is that there are loose, free-floating nucleotides that the RNA just brings over so that it can sit. Let me go back to the other picture for a minute. All right, all right, and there he is. Now everybody's here. All right. Okay, so then the first picture, the DNA opens up, unzips, and in the middle, the first picture that I put up was really your DNA replications making a copy of DNA, but it's the same thing for RNA. The DNA unzips, and that template, the free-floating ones that are coming in are now RNA. Okay, they're going to float in, free-floating nucleotides are going to float in, and they're going to line up on the open part of the DNA. And then it's going to leave. So now in our middle picture, we have transcribed. And again, that's kind of a great picture because it shows you just a part of the DNA opened up. So that middle piece opened up, That little black strand in the middle represents the transcribed set of DNA because it's only transcribing for a particular activity. Each one of these is coding for a particular protein to be made. So that strand of messenger RNA now leaves the nucleus. Remember, the DNA never leaves the nucleus, and it goes to the ribosome. And the ribosome is a small little organelle. If you remember on your cell structure, they look like little dots all over the place. So the messenger RNA goes through the ribosome like a little conveyor belt. And as it goes through, the transfer RNA say, those are the three messages on the code. Let me go get that amino acid. And on the end of each transfer RNA, there's a little amino acid. So it brings it to the code, it lines up, and then it leads, the amino acids connect, and the transfer RNA leaves and goes and gets another amino acid. Okay? Each one of the transfer RNAs is unique in that it has the complementary code to the message on the messenger RNA. Okay, so it's kind of like looking in the mirror for the messenger RNA, taking a picture, but it's a negative. And then when it comes back, the transfer RNA reads the negative and prints the picture the way it's supposed to look. Okay, so that's how that. All right, learning how to do this chart. All three sides have a clue for you. First letter, second letter, third letter. So every amino acid has a triplet code, 3 letters in a row. And you can figure out what amino acid that you're looking for by going first letter, second letter, third letter, and you kind of line them up with your finger and you decide where you want to go or what amino acid you need. The second way to do this is to use the circle, and it works by starting from the middle and you work your way out. Okay? All right, going to the worksheet. So we started the worksheet the other day. I think I did 3 of them for you at the top, 3 at the bottom, and then we stopped just before the transcription, but I'll go back and do them again. All right, and I'm just going to go down the first column. So again, you should be doing this with me so that by the end of class, you are ready to submit this worksheet. Like again, everybody's present, so nobody should have a missing worksheet by the end of class. All right, the other thing I wanted you to remember, if you didn't write it down somewhere. Somebody in the other class kept asking me, how do you know what to match with the G and the C? And we did the first DNA thing for you to do all the color coding so that, and they were puzzle pieces because they fit into each other. They complement each other, and they're the only complements. A doesn't fit G, C doesn't fit A. Okay, so G always goes with C. And if you didn't write it down somewhere. G matches C every time, because it's going to be important when you do the code at the bottom. A matches T always on a DNA strand, but we're dealing with RNA strands today. So T is always going to match A, but A is going to match U. Okay, if you look at this chart, there are no T's on this chart, right? Because this is all about RNA. So RNA is only going to have U's, no T's. Okay, so if there's an A, like some of these have A's, it will match U. It will not match T. All right. Okay, so again, the first one was CCC. So you go on first letter C, that tells you the second row on the chart. Top of the chart for the second one is also C, so that's second column. So I come down, run my fingers together, come down to that box of the second column, second row, and my third letter is also C. So I find that in the box, and that tells me my amino acid is proline. Everybody should have proline written down on the line. And it's okay for the top that you write PRO, that's fine. Proline is actually spelled for you down here if you want to write it out. Okay, now it just so happens that there are 4 different ways to get this particular amino acid. So when we do this question down here, you need to write all 4 ways. All 4 sets of codons will give you this amino acid. Okay, I'm kind of going to do both at the same time. All right, next one, CAG. So again, the first letter is C, so that's our second row again. Go up to the top, find the A, that's the third column. So I'm coming down from the second row, third column, and the last letter is G, that's the one on the bottom, CAG. So the amino acid we're looking for is GIN. Okay, so you're going to put GIN on the line. All right, third one is GAA. So we're going to start with G on the first letters, the fourth one, the little blue box on the first side. A is at the top is the third column, the green one. So we come down the green column, down back to our fourth row. And now we're looking for A. So GAA is going to give me glucine, GLU. That's the letters you write on the line. Okay. All right. Anybody's lost? Anybody still not understand what I did or how I found it? All right. You got to do the rest. All right. Down here, you want to do the same thing, except they're giving you the name. And they also highlight the first three letters because the chart only has the first three letters. So again, we did the first one was proline. What you have to do is write all of the codons. Some of them have more than one. So if they have, in this case, it had 4. So you write all 4. Valine is the next one. So I come up to the chart. I look for VAL. This one also is the first box. Whoops. Yeah, valine. So it's the first box with G, first column, last row. So there are also 4 amino acids for valine. So you write all 4. The next one, histidine. I come up and I look for HIS. This one only has 2. So second row, third column. HIS, this one only has 2, so you only have to write 2. Okay? All right, so that's what you do with these. You just come up and you find the 3-letter code and then see how many codons there are for it and write those on the line. All right, 3 and 4, the amino acid chains. Again, think of the protein as a string of pearls with beads on it. And there's one bead that starts to make the thing. It's always methionine. There's only one that starts it. So if you come up here to the chart, you see this yellow line up here. It tells you that's the start codon. On the circle, it's not highlighted, but it does say so out here on the outside of the wheel that methionine is, and there's only one code for start. Okay, so you have to write the code for start on the line. For stop, if you look up to the top of the box, the orange shaded ones, there's 3 different codes to stop. So you write all 3 of those codes on the line. And on the circle, again, it's not highlighted, but it does say stop 3 times off to the top of the chart. Okay. All right, so you're going to fill in, that's for 3 and 4. All right, now everybody needs to have their listening ears because this is where you have the real work to do. And there's actually a flaw in this worksheet because it should have 2 rows of RNA. Okay, so what we should have is a transcribed row of RNA and then another transcribed row for transfer RNA before you go looking for the amino acid. But this is practice, so we're not going to get that complicated. But technically, that's what should happen because you're going to run into a problem I find with these over here. These both say stop, and you can't have 2 stops in a row. So the reason it's doing that is because they're both saying transfer RNA. However, all right, so let's do it. So again, this is where you have to remember who matches who. So I'm only going to do the first 3. They're set up in groups of 3. So there are 5, and each row has 5 sets of 3. On DNA, it's not really like that. It just reads it in sets of 3, but they separated them so that you don't get confused. All right, our first set is TAC. So this is a DNA strand. We've got to turn it into an RNA strand. All right, so T will code with A. Okay, so write that down. T codes with A. A, remember, would code with T, but this is RNA, so it's going to code with U. And C codes with G. So our first set is AUG. Okay, write that down. All right, so then we're going to go up here to the chart and we're going to look for AUG. So again, A is the first one, that's the third row. U is the first column. Come back down, AUG, and just as it should be, the first one is the start codon. AUG is methionine. So you're going to write for the name of the amino acid is methionine, or you can just write MET. Okay? Everybody follow? I'm going to do the second one and then I'm going to leave you. All right. Second one is CAT. Nice cat. All right. C complements G. So our messenger RNA has a G. A, again, on our messenger RNA is going to match up with U. And our T is going to match up with A. So we have GUA. All right. Then we're going to come up to our chart and look for G, which is the last row. And up again, it's the first column, and A, and it's going to be valine. GUA is valine. So you're going to come back down here and where it says amino acid, write valine. And then you need to put little lines to link them together because that's what really happens. The amino acids link together to form a chain. So just put a little dash in between each one as you create it. Okay? Now, like I said, typically the last two on this one are not correct. Well, the last one is, but the second to last one, because they're both going to end up telling you stop. And that's usually, if this was translating to a transfer RNA, it wouldn't do that. But for practice sake, we're going to leave it like that. Okay, so you're just learning how to translate one thing to the other and go up to the chart and find an amino acid. All right. When we do this again, and we will do this again because our next step is to look at how do we get mutations. Okay, so we're going to do this again. So if you don't understand, please tell me so I can keep explaining. Everybody good? All right, so again, I've practically gone through most of the worksheet, so there should be no excuse to not have this worksheet turned in. I did do letters home, and I don't think anybody in here got a letter home, but some of you are kind of borderline. So if that's you, please make sure you turn in anything. There's two of you actually. That's outstanding so that we get out of that 60 range and get into a passing range. All right, no questions. I'm going to stop sharing, do attendance. If you have a question, please do ask. And again, everybody should be working on this because this is due at the end of class. Finish this first. If you owe something extra, do that after you finish this. And if you finish all of that, read the section, go back to Canvas and read the section on mutation. It's the very next section. Right after the chart. So you have It says DNA mutations is the name of the lesson. It shows you the chart, and then underneath it, it talks about, excuse me, mutations. There's a video to watch. There's an activity to do. And there's a list of types of mutations. And you're going to have a worksheet that's going to ask you, what, if we have this type of mutation, what kind of disease do we have? Okay, so please do read that when you're done. No, it's actually, it's, okay, give me 1 second. I kind of changed pages too quickly. It should be, hold on, I'll pull it up. If you look in your, if I want the correct spelling of the amino acids, the, the wheel that's on in your Canvas page actually has them spelled out. So if you're looking at this page, can I try to zoom this out a little bit? Okay, here we go, because it's so tiny. All right, so we can go one more time. I can hardly see. All right, so we've got glycine, we've got glutamine, and we've got, because I think that one might have been an error in spelling on the chart. Histidine, glutamine. So that should be GLU or GLY. Let me see what's here. Yeah. So that's an L, not an I. GL. It should be GLU as a GLN on there. It's abbreviated. So some of you are writing that as I. It's GL. And I said Jen, I'm sorry. It's GLN. N is the abbreviation, and that's for glutamine. I don't know why it's N. It should be GLU. They have an N on that word on that chart. It should be a U. GLU. And this is upside down. So it's GLU or GLY for those two. For the abbreviation for the amino acid. Okay. Oops, I didn't mean to do that. All right, the other thing you need to remember is there are 20 different amino acids. Like your alphabet has 26 letters in the alphabet, there are 20 different amino acids. Depending on what arrangement you put the letters in will determine what we're going to call this amino acid. Okay, so again, the chart codon table over has the names spelled out for you. And that's the page right after the activity. Mutations. And again, if you finish the worksheet, as you will finish the worksheet, come back and read this page over. And then we're going to talk about mutations next. So depending on what type of mutation you have will determine what type of disease is caused. All right, you go, Professor. All right, so it can be done, folks. It can be done. And we've got plenty of time. All right, so read through this. We'll you can watch the video by yourself. I'll have another one on Tuesday, and we'll look individually at these, but make sure you go through and talk about the types of gene mutations. See, look, especially study this one. You got missense, nonsense, and no sense. All right, so it's a lot to read up on. So do read, do read, do read. All right, let me see if I can get my screen back to being normal size. Now, sometimes the computer don't like when you mess with it. All right, take that back. It is GLN, so it's glutamine and glycine. So there's one for glutamic acid. So there's three of them. There are three. It's glutamine, which is GLU. There's glutamic acid, which is GLN, and glycine, which is GLY. All right, so again, if you finished the worksheet and you've submitted it already, please read the mutations section in Canvas. It's a lot. You have another activity to do. So make sure you go through the slide presentation on the different types of mutations. right, don't forget on question number two, you need to put all of the code on. So some of them have four, some have two. Are you popping in and out? Quite a few people are having computer problems today. Okay. All right, so again, this worksheet is due today, so you shouldn't be doing anything else if you haven't turned in this worksheet first. Again, there's no reason for it to be late. Doesn't take that long. Xander, please turn in the worksheet first before you do something else. Brooklyn, check yours. Imani, check yours. All right, folks, each one should have 5 amino acids. All right, there we go. All right, time is just about up. Hopefully everybody's turned in their worksheet. And you all are free to go. Have a great weekend. Be safe. Enjoy.